In this video, I'm going to show you how to carry out an MCT, a machine compliance test, in compliance with IEC 60974-4. That's the international standard for the periodical inspection and electrical test of arc welding equipment. We open a machine compliance test report form, and as with the calibrator and validation process, create a new report. The same as those, we can use the database and select a customer, and as before, record the manufacturer. We've got a Miller. And then record the model. This is an STI 203. And then we'll enter the serial number. As with calibrations and validations, we get this information from the data plate. We then ask to enter the plant number, if there's one available. There's not on this machine, so we can just pass that box. We'll then record the supply voltage. On this unit, it's 400 volts. And we'll record the plug fitted. Using the up and down arrows, you can select which plug is fitted. In this case, it's a 32 amp 5-pin plug. And then we'll record the ambient temperature, 18 degrees today. Once all that information's entered, we can then hit the start button and we're ready to carry out the test. The first test we'll carry out is a visual inspection. Now there's a long list of things we do need to check on the visual inspection, but in the program we do have quite a handy little view protocols box that will actually list what needs to be checked. We need to check the torch and electrode holder and the welding clamp, looking for anything that's missing or defective on the connections, on the insulation, on the switches, and any other damage. We'll also look at the main supply, checking for defective or damaged cables, deformed or faulty plugs, broken or thermally damaged plug pins, ineffective cable anchorage, cables and plugs unsuitable for the intended use and performance. We'll then check the welding circuit for any defective damaged cables, deformed, faulty or thermally damaged couplers or sockets, ineffective cable anchorage, cables and couplers unsuitable for the intended use and the performance. We'll then check the enclosure for any missing or damaged parts, unauthorized modifications, cooling openings blocked or missing air filters, for any signs of overload or an improper use, missing or defective protective devices, for example gas cylinder holders, missing or defective wheels, lifting means, holders, etc., defective wire reel mounting means, and conductive objects placed in the enclosure. We'll also check the controls and indicators for any defective switches, lamps or meters, defective pressure regulator or flow meter, incorrect fuses accessible from the outside of the enclosure. Finally, we'll check the general condition for any excessive dust or pollution, the cooling liquid circuit leaking or incorrect cooling liquid level, defective gas hoses and connections, poor legibility of markings and labelling, and any other damage or signs of improper use. If we're happy with all that, we can give it a pass and move on to the next test. Our next test is test 1, the protective conductor resistance. This is where we're going to measure from the earth pin in the plug to the chassis of the machine and make sure it's within a given tolerance for resistance. On this machine, there's nowhere to actually attach our crocodile clip, so I'll use a small adapter to get our chassis reference point. We're then ready to connect up the MCT unit. We'll connect red to positive, black to negative, and the yellow to the chassis. For the positive and negative, we can use the DINS adapters. And then for the primary supply, we have a little adapter there. Now we're all connected, we're ready to carry out test number 1, the protective conductor resistance. We're asked the cable length. This cable's up to 5 meters. The tolerance does change the longer your cable goes. There's different tolerances all the way up to 57.5 meters, but this cable, which is pretty standard on most welders, is up to 5 meters. That gives us a tolerance of 0.3 ohms. So in test position 1, we set the mega to ohms. So we record 0.14 ohms in the measurement box, which is a pass. And then we can move on to the insulation resistance tests. We are asked, can the insulation resistance test be carried out? There are some equipment out there that we know we cannot do these on. Generally, most welders can, there's not a problem. So if in doubt, hit yes. And we're reminded that before the next test, we must ensure that the primary switch is in the on position. And if applicable, we need to ensure that the contactor is manually pressed in inside the welder. So test 2, we're going to test the primary circuit to the earth. We rotate to test 2. We press the test button and we can see the megohms rising and rising and rising. We've got 284 megohms there. So we enter that into the measurement box. We'll then move on to test 3, where we check the secondary circuit to earth, the welding side down to earth. Again, in the 500 volt setting, press the test. We can see the megohms rising and rising and rising. We've got 334 megohms, massively above tolerance. We enter that into the next box. We move on to test 4, checking the primary circuit to the secondary circuit. Rotate the tester to test 4 and press the test button. Again, the megohms are rising. It hits 387. We record that value in the measurement box. If at any point any of the values are out of tolerance, you will get flashed up a notice asking, can the problems be resolved? And if so, we can continue the test. We'll then move on to test 5, the no low voltage test. And we're going to have to find out firstly, does this machine have an S mark? We refer to the data plate for that. We hit enter, yes, the machine has an S mark. And we're going to take our voltage reading in DC. We need to turn the machine on now, so we'll remove the primary and the earth cables and plug the machine in. Remembering to leave in the positive and negative terminals. With the machine turned on and the VRD, the voltage reduction device, turned off, we'll rotate the tester to test 5. We have 5A for DC, 5B for AC. This machine is done in DC, so it's going to be test 5A. And we rotate the mega around to the voltage selector switch. We need to adjust the 200 to 5K resistor from minimum around to maximum and record the highest value that's shown on the meter. In this case, it's 54.6. Finally, we're asked, is a function test required? If the machine's in service, there's no need to carry out a function test. If the machine's had a repair, you do carry this out. In this case, we're going to say yes, the machine's repaired and carry out a function test. And then we're asked to check the safety related functions. Is that a pass? The switch, is that operating correctly? Gas, we do a simple drop test, make sure there's no leaks. The VRD, voltage reduction device, we check that's operating. If a machine, such as a standard switch MIG, which doesn't have a VRD, you can just click NA, not applicable. And lastly, we're asked about the indicators, are they operating correctly? If so, hit pass. When the function test complete, we move on to the status tab. It takes us into the retest state. It's set as standard for 1 year. Some applications, such as dockyards, outdoor use, might require a 6-month retest, but as standard, keep it as is. Finally, attach a label of who's carried it out, the due date and a certificate number, and attach it to the machine, and then your safety test is complete.